Welcome to Study Loop.
Okay, first of all, let's see the definition of omega in terms of calculus. So, omega is the change in angle theta with respect to time. Then we also need the angular momentum, which is I times omega, and we also need torque, which is change in angular momentum over time. So, this L and this tau is something that we need to evaluate in part B. So let's talk about part A first, where we need to figure out the units of A and B. So the expression that we have here is theta equals AT squared plus BT to the power 4, right? Now here we see that the unit for alpha must be radians, right? Because the unit for theta is radians, so this is radians. Now the unit of this t squared is second squared. Similarly, for t to the power 4, it's second to the power 4. So that means we must have something related to radians here to get radians back. And also we need to get rid of this second squared here and second to the power 4 here to get rid of the time component. So we'll have just radians here. So if we do so, we see that for A, they should have radians per second squared, so that this second squared gets cancelled with this. And then for B, it's going to be radians per second to the power 4. So that means A will be 1.5 radians per second squared, and B will be 1.1 radians per second to the power 4. All right, so in part B, first we need to figure out L. So L is, again, as we mentioned, I times omega, where I is, so since it's a thin walled sphere, hollow sphere, so it's 2/3 mr squared, right? Um, also, we know that m is given as 12 kg and r is given as 0.24 meter. So using those numbers, we can figure out this I right here. Now, what about omega? So as we mentioned here, omega is d theta over dt. Let me write down that here as well. So that means it's a derivative of time, derivative of theta with respect to time. So if we do that, we see that we'll have ddt of a t squared plus b t to the power 4. Now the way we do the derivative here is first we take this number, the one that's in power, in front of a, and for here in front of b. So for example, here it will be 2 times a, then there's t. Then what happens is this power gets reduced by 1. So 2 minus 1 gives us 1. So this is just t. Similarly for b, 4 gets placed before b. So we have 4b. Then this gets reduced by 1. So 4 minus 1 gives us 3. So that's t cubed. Right. So this is our omega. Now omega at t equals 3 seconds. Let me write down with a different color. So this means omega at 3 seconds. So omega at 3 seconds will be 128 radians per second. So if we use this number and put these to calculate I, so if we then multiply I with omega, we'll get L. So L will be I times omega again, where if we calculate this, we'll see that this is going to be 59 kg meter squared per second. Okay, so what about the torque? Now we know that torque is dl over dt, which can be written as I times d omega by dt. And the reason for that is this is ddt of I times omega, where I is constant, so we take I outside. That gives us I times ddt of omega, and that's what we wrote here. Now, what about this quantity? So we say that this will be ddt of twice at plus 4bt cubed. So we'll do the similar thing that we did before. So since the power is 1 here, so 2 gets multiplied to 1, which is 2. So we have 2a. Then t will have 1 minus 1, which is t to the power 0. So t to the power 0 is 1, so that's why there's nothing there. Then 3 will come in front of 4, so 3 times 4 gives us 12. B, then t gets reduced by 1 power, so 3 minus 1 gives us 2, so this is t squared, right? Again, we know a, b, and t, so t at 3 seconds. Then I is all, we have already said how to do how to calculate I. So if you put I and this quantity right here, d omega d alpha, we see that we get tau or torque as 56.1 Newton meter. So you should do the calculation by yourself. All you got to do is put a and b and t here for d omega dt, and for I you just have to put the mass and radius to get the I. So once you know your I and d omega dt, you just multiply them together to get the torque. Thank you.